Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 6.2.4. We're going to start off with our M&Ms, where we officially get in our notes what it means to define a variable. So when you are reading through a problem, you've got all these different parts to the problem, and the variables are all different parts that play a role within the problem. Some of them we can define easily. Others we have to define with an actual variable, which would be like the x here. So if it says at the neighborhood grocery store, grapes cost $3 a pound. If Belinda buys $5.40 in grapes, not on grapes, how many pounds of grapes did she buy? Well, the variable in this case is the number of pounds, right? So we would make x equal or represent the number of pounds of grapes. And we know that the price is $3 per pound, so 3 times the number of pounds has to equal 5.4. So a lot of times we just use an x to represent our variable. If we had situations where we had like more than one variable and you were having trouble deciding, well, one of them is x and one of them is y, sometimes students will actually choose a variable that makes sense, like the number of pounds. We'll just call it g instead of x because the g stands for grapes. Okay, so just to finish out this problem, we would divide 5.4 by 3, and so x has to be equal to, let's check this out, 5.4 divided by 3. That would be 1.8 pounds of grapes would be the amount that was purchased. All right, so here we are. For the end of year party, Mount Rose Middle School ordered 112 total pizzas. There were 8 fewer veggie pizzas than there were pepperoni pizzas. And there were 3 times as many combo pizzas as there were pepperoni pizzas. So how nice is that? The pepperoni pizza is being compared to both the veggie and the combo. So we can make that our x. 3 times as many combo means that would be 3x, would be how we would define the number of combos. And 8 fewer veggie pizzas than pepperoni would mean that we would have to say x minus 8. The total was 112. Okay, so in our describe portion, we are going to include the definitions, and I also wrote down the question is they want us to determine how many of each kind of pizza. So when we declare our answer, make sure that we say the number for all 3 kinds. Okay, so if we wanted to solve this using the table, you can just make up a number for pepperoni pizzas, triple it for the combos, and take away 8 for the veggies, and then add those numbers together and try and get a total of 112. Well, that's too low, that's too low. This is the winning combination right there. So let's see how long it takes to solve it algebraically, where we've got 1, 2, 3, 4, 5 x's minus 8 has to be equal to 112. When we combine like terms, simplify this expression, it becomes 5x minus 8. So let's solve. Let's start by adding 8 to each side, because we want to know what 5x was equal to before we took away the 8. So 5x's must have been equal to 120, because 120 minus 8 is 112. Now we will divide by 5, because if 5 times x equals 120, then 120 divided by 5 will tell us what our x is. And it turns out 120 divided by 5 ends up being 24. So we prove it. 120 divided by 5 is 24. Okay, so now we know. We know the number of pepperoni pizzas. So we triple that number, 72 for the number of combos. We take away 8 from that number, that's the number of veggies. And when you add 24, 16, and 72, 24 plus 16 plus 72, that gives you the total of 112. So we can declare our answer. There were 24 pepperoni pizzas, 16 veggie pizzas, and 72 combo pizzas ordered by the middle school. All right, consider this equation. 7 equals 3x minus 5. Stanley wants to start solving the equation by adding 5 to each side, while Terrence first wants to subtract 7 from both sides. Will both strategies work? Well, yeah, they actually do. I mean, watch what happens when I do what Terrence wants to do. As long as you are doing legal moves, you can do anything you want. I could have added 100 million to each side, and that would have been a legal move. It wouldn't have gotten me any closer to my answer, but I could have done it if I wanted to. So what Terrence is doing is just going to require him to take a little bit more time to solve his problem. -5 minus 7 is -12. So once you're here, then you would have to add 12 to each side because you want to get your variables on one side and your constant on the other. So they cancel out, leaving you with just your 3x's and your 12 on this side. So notice that is exactly the same thing that we have right here. So Stanley, doing his move, he decided he wanted to get the x's all by themselves as his first move by adding 5 to each side. And he got 3x's equal to 12. Well, Terrence took 2 steps to get there, but at least he got there. And so the last step is going to be the same for both of them, dividing each side by 3. So you see that x is equal to 4. Okay. All right, we got 2 triangles that are similar. What is the scale factor between shape A and shape B? So in order to find the scale factor, you're trying to figure out what would you multiply times this side here to give you that side there. And this is a kind of a tricky problem because the 2 triangles are not oriented the same way, right? This side here is not what's the word I'm looking for? Is not in the corresponding location of this triangle. This triangle, its shortest side is 20. This triangle, its shortest side is 8. So those 2 sides correspond to each other, and that's how we're going to figure out the scale factor. What would you multiply times 8 to give you 20 for an answer? Or if you wanted to go in the other direction, what would you multiply times 20 to give you 8 for the answer? So in this situation, the scale factor is 2.5, which is technically 5 over 2. So if we wanted to go in either direction, you could use either 5 over 2 or 2 over 5 as your scale factors, depending on which direction you're going in. So this side is the longest side. So I'm going to make sure that the 16 and the t correspond to each other when I'm solving this problem. To get the value for t, I'm going to have to multiply 16 times 5 over 2, because that's the scale factor that's greater than 1, and t is greater than 16, so you have to have a scale factor greater than 1 for this to grow. On the other hand, 35, that's the medium side, that corresponds to this one. We're going to have to multiply 35 times the scale factor that's less than 1, because s is shorter than 35, because this is the smaller triangle. Whenever you multiply a number times a fraction that's less than 1, you are going to get a number that's less than the number you started with. So let's go ahead and work through this. Let's start with s. So we're going to start with our 35 over 1, and we have to use this scale factor because s is smaller, so we'll multiply times 2 over 5. That gives us 70 over 5, and 70 over 5 is the same as 14, so s has to be 14 units, whatever our units are. Do the same thing for t. We started with 16 over 1, and we're going to multiply that times 5 over 2. And 5 times 16 is 80, and 80 divided by 2 is equal to 40, so that means that t would have to be 40. And that makes sense, right? Because t is the longest side, so it's got to be more than 35. Same thing applies over here. This is in between 8 and 16, because 16 was the longest and 8 was the shortest, so 14 falls between there. Yeah, those absolutely make sense. And then if you wanted to make a smaller instead of bigger, what scale factor could you use? You'd use anything that was less than 1. So whenever you multiply times a scale factor that's less than 1, something is going to get smaller. If you multiply something times a scale factor that's greater than 1, it's going to get bigger. Problem number 100. Ooh, joy. Lots of work to do here. All right, I don't think I want to go through and do every single one of these. Just know that 3 of these are going to use the formula for areas equal to base times height to figure out their areas. The triangle is the exception. This one, you take half of the base times the height to find the area of this triangle. As far as perimeters go, you're just going to add up all the sides. So understanding that with parallelograms, the opposite sides are always the same measure. So if this is 10 1/5, this would be 10 1/5. If this is 7 3/4, this would be 7 3/4. Now, I would say this. Some students like to change their fractions to decimal numbers and then add those together using calculators and multiply them together using the calculators, and that is absolutely fine to do that. The problem is when you get to this fraction here and this fraction there, because you can't write those in decimal form without rounding them off because those are repeating decimals. So in this situation, it's probably better if you just stick with the fraction operations to solve the problem. So I am going to leave this up to you. If you need me to work through any of these, just ask, and I will work through any of them. Otherwise, I'm going to assume that you know the basic premise and you've seen what the correct answer is. You should be able to go look through your work and figure out where you made your mistake and how we get to the correct answer. All right, factoring. They've been doing a lot of factoring lately. This is interesting. Okay, so 90K minus 60, if I want to factor out the greatest common factor of those two numbers, 10 goes into both of them, 15 goes into both of them, 20 does not because it doesn't go into 90, but 30 does. So if I divide out both 30 on both sides, 90 divided by 30 is 3, so that becomes 3K, and 60 divided by 30 is 2, so that becomes 3K minus 2. Now, how do we know that's correct? Because if you send in the dive bombers and do distributive property, 30 times 3K is 90K, and 30 times 2 is 60, and there's a minus sign in between those two terms inside the parentheses, so that's what we need. Here, same idea. What goes into both 18 and 30? Looks like 2, looks like 3, and 6. That's it. 2, 3, and 6. So the greatest of those is 6. So 30 divided by 6 is 5, and 18 divided by 6 is 3. But they also have d's in common. So you could divide out a d that they have. This is d squared, which is d times d, and this is d times 1. So you factor out the d's as well. And now make sure, and I'm going to do, instead of sending in dive bombers, I'm going to send in the torpedoes because I don't have room here. So 6 times 5 is 30, and d times d is d squared. 6 times 3 is 18, and d times, there's nothing to match with the d, so it's going to stay as the d, and then there's a minus sign in between them. So yes, those are both correct. All right, write an expression for each mat at right. Simplify each mat to determine which expression is greater. If x is equal to 3, would your answer to part A change? Okay, so let's get started. This is 1x plus 4 plus a negative 1. This is 2x's plus 2. Now when we remove balanced sets, take away an x from each side, take away 2 from each side, and this should be in red because that's a negative. That's a positive, that's a negative. That's a 0 pair. These are removing balanced sets. So once all was said and done, you ended up with an x on one side and a 1 on the other. So, can you tell which side is greater? No, you absolutely can't, because we don't know the value of x. If x is equal to 0, then side A, mat A, would be greater. But if x were equal to 10, then mat B would be the greater one. So without knowing the value for x, we cannot determine which side is greater. If x was equal to 3, would we be able to? Yeah. If x was equal to 3, then this 3 would be greater than 1, right? Mat B would be the greater one. And if x were equal to negative 2, then 1 would be greater than negative 2, so mat A would be the greater mat. And that ends it. All right. Let's move on. Oh, wait, am I doing that right now? No, I'm doing this right now. Yes. All right, let's move on to the next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. feeling blessed.